Alright, so now I'm going to solve this Leetcode medium problem, grouping anagrams. So from the description, we are given that we have an array of strings and we need to group each anagram to its own array. As a result, we would get an array of arrays with grouped anagrams. And the description says the letters are going to be all lowercase and only English alphabet letters are going to be used. So at this point, I have one solution in mind, that what we can do is we could correspond each letter to an English to the position. We could create an array, and we would have an array of 26 letters that corresponds to the English alphabet, and for each letter, each position in the array would represent a letter. And if we have 3 letters repeated, we would just increase the value in that position of the array. So for example, we would have, let's say, I'm going to create a group. Yeah. And in this group, for example, I would have, let's say A is going to stand for position 0. Then we're going to have B at position 1, C at position 2, D at position 3, until we reach Z that is in position 25, because the length of the array is going to be 26. Let's make it, yeah, for example, let's say there is a word which is ABC. Let's make it simple. We have, let's say, ABCC. We have A repeated once, B repeated once, and C repeated 2 times. And we don't have any other letters, and we would have 23 letters with value of 0. And if we have the same word in the array, which could be the same word, even positioned in the same way, or we might have something like this, CBAC, or we could have, let's say, CCAB. And we can think of very different rearrangements here, but we would have the same result in our key. It would, for all of them, it would represent the same key, and for those words we can create an array to group them and just place those words in this array. I'm gonna place this and place the last one here. Yeah, this solution should work. So for that, we need to loop through an array of strings for each string, and we also need to loop through every letter in that string. Let's create an array here. So for let I is 0, I less than string.length, and I++. To retrieve the how do we know that A is going to be in position 0, Z is going to be in position 25? So since we have only lowercase letters, we could use JavaScript's character code at function. Let's first check how it works. Gonna use developer console. Let's use developer console. character code at, we could pass 0, we could pass nothing because we only have one letters. So as you can see, it returns 97. For Z, we would have character code at 122. So if we're gonna subtract 97 from each letter's character code, then we would have the exact position in our array. For Z, it's gonna be 122. Yeah, minus 97. This should really give us 25. Yeah, this is the last position in our array. Let's check the Y. It should be 24, right? Character code at minus 97. Yeah. Let's check B. The code at minus 97. We have 1 position in our array. Okay, so we can use this information here to create our alphabet key that is going to be used in group object. So in this case, we would have something like this. Alphabet of, let's retrieve that index. So it's going to be constant index string of I minus 97 string of I dot character code at minus 97 is going to be our index, and we will just increment it by 1. But we might have so first of all, let's say we encountered a position 0. So position 0 is the value in position 0 in our array is undefined since we have an empty array. So I would just since we already know that our array is going to be of 26 letters, I would just fill it with default 0 values. Yeah. We need to fill them with zeros, because since we said our key is going to represent repetition of each letter, let's say if we don't encounter letter T, we would have 0 at some point in our array. For let's say we encountered A one time, Z one time, then all other positions should be filled with some value. So we could stick with anything here, but this would be more simple. Let's see what our alphabet is. Console log alphabet. Got an error. Character code at. Yeah, as we can see, we have an array for each word in our array of strings. For each string, we have its alphabetical representation with how many letters repeated how many times. We know exactly that. From knowing that, we can push to this group's key. So since we need to create an array of groups, array of repeated words in our group object. But in the first step, so let's say we would like to push this word, the eat, to our group. At this point, we don't have anything in our object. So if we don't have the group yet. I mean the group of repeated words yet. So in our case, it's going to be key alphabet is going to be our key. If we don't have it, then we're going to create an array with this key and just put the current string in there. If we already have a group of this key of, it could be E, it could be D, then we're just gonna push to that group our current string. Let's console log the group. Yeah, as I can see, we have all words grouped together. See the case 2. Even for empty string, we have 26 zeros. For only one word in the array we have. Yeah, it works. Okay, so at this point, since we have an object with keys and values, we should just retrieve the value of this object and return it. It will, yeah, I think this should work. Return object dot values of our group object. Let's run it first. If it works, then I'm gonna submit. Yeah, it did work. Let's submit. It's beating only 22%. Maybe there is a faster solution to this. What if I would just sort? What if I use sorting? At this point, our complexity is going to be, so we are looping through an array of n strings. It's going to be bingo of n. And we have another loop here. We have a string of lengths. We could take it as k because we have two different. We don't know the length of every string. It's not going to be n. It's going to be k because, or n as a letter, it could be l. It's just represented as l. So our time complexity is going to be n times l. L stands for the length of the current word, and n is the length of the array. What about space complexity? So since we are we are pushing to the array every single word, and the maximum we could have is if we had every word that would be unique, that would not be in the same group, then we would have to create, let's say if the string is of length 100, strings array is of length 100, and we have 100 different words, then it means we have to create 100 arrays in our group object representing each word. So our space complexity is going to be big O of n. We don't count this because this is a constant time, because we already know that English letters are not going to exceed 26, and we should just count it as constant time, and our space complexity would be big O of n. Let me try other solutions and see how those work. JavaScript. Looks like this one has a lot of sums up. Let's try this one. Oh, it's 50% faster. That's great. Let's see this one. Woo, it's beating 94%. Wow, and the memory usage is great. Looks like this guy is using sorting. But how does it? Let's try to run our solution once again. Maybe we can also get a better result. Nah. So here, sorting is used. A string of strings. So creating an array from a string, then sorting the letters and joining them. Yeah, here at this point, I think this would just have, yeah, letters like this. For example, if we had A, B, C, D, no, let's say D, C, C, B, A, for example, sorted would be equal to A, B, C, C, D. Yeah, this is a good point to find out, to create a key. It just depends on how you create a key. Looks like the key creation here is faster than in my solution. Looks like so. If map has sorted, if map has this key, then set the map. Yeah, he's just retrieving the old values and pushing the new string. If it doesn't exist, I mean, if the key doesn't exist yet, then it's just gonna be the array of one key. Yeah, it looks like this solution is faster, but um, what is the time complexity of this algorithm? Is the map? I think this is the one. Yeah, k log k for sorry, but it looks more complex in my solution. But as a result, it's faster because in my case it was n times k, but here we have n times k times log k. Yeah, looks like the key creation here is much faster. All right, I'm gonna pause here